Now we are focusing in this geography topic, that is about precipitation. The word used here, that is precipitation. That means the way water is coming out from atmosphere. Now first thing here, the presence of water is there in range of 16 kilometer from sea level. If you are there on equator, somewhere around 16 kilometer, and if you are there in polar region, then just 9 kilometer. In that range, water is present in atmosphere. If you are flying beyond 16 kilometer from sea level, there is no presence of water in atmosphere. So in vicinity of surface, say because Mount Everest is the highest peak on this earth, which is not having height greater than 9 kilometer, and it is not in polar region. The reason that on Mount Everest also, if you travel, you will get presence of water vapor. But if you are flying beyond 16 kilometer, in atmosphere there is absence of water molecule. Now whatever water is present in atmosphere, that may come out in various forms. Say for example, it can come out as water, it can come out as water droplet in form of dew, it can come out as rainfall, it can come out as cloud only, it can come out as hailstone, or it can come out as snow. So like that, various formats are there. Let us check out one by one. First thing, I am considering here a case at sea level. Say this is the level of ocean or sea. Water start evaporating out. There is difference in boiling and evaporation. Boiling occurs at particular temperature, evaporation occurs at any temperature. From any temperature you can get water vapors here. So here oceans or sea, they are having average temperature 15 to 20 degrees Celsius, suppose. Then also evaporation of water is continuing. This evaporated water, that means what we are saying here, the gaseous molecules of water, they are present here, or molecules in gaseous state, they are present over here. Their amount start increasing out. That means what we are saying, absolute humidity start increasing out. As absolute humidity start increasing out, the value start attaining a stable concept, that is saturation point. This way this will become more and more saturated. Now second thing, during daytime, as temperature rises, these water vapors start moving at higher altitude because there are air currents. When air get expanded, it become when air get hot, it become expanded. As it expands out, its density decreases. See, the formula of density, you are aware, density is equal to mass upon volume. As volume increases, density decreases, and therefore air start moving in upward direction. Now you can ask question here, that as sun rays are coming out from sun to earth, why not upper part of atmosphere get heated first and then lower part? The answer is that our atmosphere is transparent to solar radiations. That means it is not absorbing to great extent. Some part is absorbed. We can discuss that topic when we are discussing out insolation. Here you can keep in mind that some part of atmosphere is absorbing the heat, solar radiation, but very few. Rest of radiations can reach till surface, either till water or till land. Now water or land, that will absorb that radiation. It will not penetrate further, otherwise there will be no night if earth is transparent. But they get absorbed in soil as well as in water. say in water also, you can say water is transparent. Yes, but part of light is, okay, let me complete this topic of physics. Smaller but important. There is a surface, say this is the surface. Some radiation is coming out. Consider this as straight line only. This is incident radiation. So as this incident radiation is there, what will happen after touching out to surface or on this body? Various cases are possible. Case number 1, part of radiation get reflected back. So this is called as reflection. Say you can observe me because here lights are there. The radiations are falling on my body or surface and reflected by my body. As radiations are reflected by body, you can able to observe me because that radiations are captured by camera, that is converted into electrical impulse, and that will go to your computer or whatever that cycle, and then you can observe light again. Now here, this way you can observe any body on earth or in the space also. That is majoritarily, we can say, one of the important part that radiations are reflected by that body. In case of solar system, the planets, they are reflecting out radiation, visible radiation obviously, whereas some planets are emitting out radiation also. You are aware now infrared radiations are emitted. Now here, the part of light is reflected back, then part of light is refracted, or I should say rather refracted, I should say transmitted. So that is traveling through that substance also, and part of light is transmitted. Now I want to show you this example. You can check out, observe this hand. Radiations are incident, they are reflected by my hand, and you are able to observe this hand. Now simply take a torch, and that lighted torch just I want to hold behind my fingers. You can observe red color in this, the light. The light is transmitted through my hands also. Not necessary only X-rays can be transmitted, but ordinary light is also transmitted. You can check out simply by closing your eyes. If strong radiations are there, strong light is there, then by closing out your eyes also you will feel some light over there. And by switching off that light, you can guess easily that light is switched off, because whatever the eyelids are there, they are also not 100% opaque. They are transmitting out light. So when incident radiation is there, part of radiation is transmitted, part of reflected back, part of radiation is transmitted. You can even check out aluminium foil is there. Usually we are using for wrapping out certain food material. That aluminium foil, you can check out. Try to observe tube light, ordinary tube light from this wrapper, aluminium foil. You may say that tube light is not visible. That means whatever radiations coming out from that tube light, they are not transmitted, they are reflected only. Aluminium foil is having a shiny surface. Now, if this is the case, then and then only, that if you are not able to observe tube light from aluminium foil, then only you can take out this tube light, take out this aluminium foil and try to observe sun. Usually after 10 AM, try to observe sun through this aluminium foil. You can observe that sun. That means solar radiations are transmitted by aluminium foil also. But if you are able to observe tube light through aluminium foil, then don't observe sun from that foil, because it may be harmful for your eyes. But you can observe tube light, that means whatever the radiations emitted by tube light, they are transmitted by aluminium foil. So what is my meaning here? That light is transmitted by even aluminium. Why I am taking name even aluminium? Because aluminium, no doubt it is light, but it is metal, and through metal also the radiations are transmitted. Only thickness matters. If foil is thick, the radiations will not transmit it to that extent. Now, third thing, they are absorb also. Now, three things we have to remember. Number one, when incident radiation is there, part of that is reflected back, part of that is transmitted, and part of that is absorbed. If you have observed the reflection from auto rickshaw or car glass, that windshield is there for car, from that also you can observe many times that sun rays are reflected out from that glass. Even if we are wearing out specs, then from spectacles also, from that glass, the radiations are reflected back. So part is reflected, then part is transmitted, part is reflected, part is transmitted, and part is absorbed. So three things are there. You can check out, if car is there in sunlight, you can touch out the glass, you will feel it warm or hot also. What is the meaning? That part of light is absorbed by that glass and glass get heated. If glass is transparent only, then glass should not become hot and it should not reflect light, but practically speaking it is reflecting. So all three possibilities are there. So incident radiation is 100%, reflected is not 100%. Part is reflected, part is absorbed, and part is transmitted. Now whatever the absorbed material is there, that absorbed substance, that means rise in temperature is there, that will give me infrared light. We are calling that as long radiation or long wave radiation. That is released out from surface now, and this released out light, that is infrared light, or simply we can say radiation of heat, that is absorbed by atmosphere, and therefore there is rise in temperature. Getting idea? So in spite, say earlier I was thinking like this is earth, this is atmosphere, here is the sun. So as radiations are entering in atmosphere, the simple thing is that this portion is close to sun than this. So this should get higher temperature and here we should get lower temperature. So as we are moving towards periphery or outside atmosphere, there should be rise in temperature. But practically speaking, the graph is not straight line. There is rise in temperature, absolutely, but not like that. We have to discuss that in different layers of atmosphere. But in whatever region we have there, the highest temperature is observed here, that is near the surface. This is the reason. I am revising again. Radiation is incident. That incident radiation, part is absorbed. The absorbed part is releasing out heat in form of infrared radiation. We are calling that as long wave radiation, and then that is absorbed by atmosphere. Now here that is absorbed by atmosphere. This is getting heated out, whereas this portion is cold. So as we are moving at higher altitude, temperature decreases, particularly the first part of atmosphere where we are living, that is called as troposphere. And in troposphere, as altitude increases, temperature decreases. As a result, the air start moving in upward direction, because as this is having rise in temperature, it is going to expand. That means volume will increase, density will decrease. The lower the density, substance will move at upward. Higher density substance will move downward, and this way there is formation of current like that. Now this way this air will move upward direction, now which is already rich with vapors, and that start moving in upward direction. As it is moving in upward direction, temperature start decreasing out. Keep in mind, from surface level, sea level, as we are moving 160 meter altitude means height, for 160 meter there is fall of temperature by 1 degree Celsius approximately. So I am using here concept, suppose the air start moving from sea level and started moving 160 meter higher the altitude. Suppose here temperature is 20 degree, at 160 meter it will fall by 1 degree, so it will be 19 degree. Again 160 meter it will be 18 degree, and like that. So as we are moving higher the altitude, temperature will decrease slowly. For every 160 meter height, approximately fall of temperature is by 1 degree Celsius. This way, initially air is not saturated here, but slowly at higher altitude it becomes saturated because temperature decreases. As temperature decreases, water holding capacity of air decreases, and there will be a point where the amount of water in given air and water holding capacity is same. That temperature we are calling as dew point. So there is dew point. Then only water will start out, that vapors will start out condensation process. But for condensation process, there must be presence of nuclei. Here, as it is moving still higher altitude, dust particles, no doubt, in troposphere dust particles are present. The water droplets, water vapors start going up. It will reach a temperature, that temperature we are calling as dew point. Then onwards, air becomes super saturated with respect to water vapors. And this is the situation where precipitation occurs in form of droplets. I am not using word drop, we are using word droplets, smaller drops. That is because dust particles are present in air and water get condensed on that dust particle, and this way we are getting formation of smaller droplets. Don't consider the moment, say at higher altitude droplets are formed, it will start immediately raining. No, the droplets will continue to move. They will form a process, we are calling that as elastic collision. That means on collision, the droplet will not unite to give bigger droplet. They will simply move back, and this way there are random motion. Usually we are calling this motion as Brownian motion. Brownian motion was observed by scientists on pollen grain under microscope. Colloidal particles are showing this type of Brownian motion, and here also smaller droplets are formed. They are showing this type of motion, zigzag. Brownian motion means simply we can consider zigzag motion, and they are moving here and there. This is the formation of cloud. I am using word again. This is the formation of cloud, which is filled by water, but water is not falling down because there is resistance of air. Number one, there is uplift or upward movement of air. Number two, these droplets are in extremely smaller size and they can float. They will not fall directly. They are not forming bigger molecule, bigger droplet because of elastic collisions, and therefore it will form only a cloud at particular level. Now these clouds, can we check out that clouds are there with water droplets or without water droplets? In sunlight, if you observe cloud that is black in color or dark in color, we are saying it is filled by water. If it is white in color, then obviously it is not having water. Why? Because these droplets are absorbing sunlight, and as sunlight is absorbed by this droplet, the light that is coming out from that cloud is having lower intensity. We appear, that cloud is appeared as dark from earth. That means cloud is not black colored, but it appears darker because sunlight is absorbed by that cloud because of presence of water droplets. Now these droplets are moving continuously. The bunch or say bulk of these droplets we are calling as cloud, and that clouds are moving with respect to whatever the wind, the direction of that wind, it start moving, and then there is friction between these droplets and air. This friction will generate a electricity format. We are calling that format as static electricity. So this way now cloud may be charged because of the friction between this air and cloud. So now you are aware how clouds are formed. That is the droplets of water, but that water is not falling. Secondly, why charge is there on cloud? That is because of this type of movement of cloud. These clouds can move upward direction, it can go at downward, any direction that cloud movement is there. The moment it start moving still upward direction, temperature will fall. You are aware now, for almost every 160 meter altitude, temperature falls by 1 degree Celsius. So this way, as clouds are moving in upward direction, temperature start decreasing out. May be possible sometime that temperature can be below 0 degree also. That is, simply we can say, we are at sea level, temperature is around 20 degrees Celsius. Suppose that cloud moves to 3200 meter high. It is 3200 meter high. For 160 meter, temperature decrease. For 160 meter, temperature decreases by 1 degree Celsius. Therefore, for 3200 meter, what way temperature decreases? So this answer is going this way, that is 1 upon 160 multiply by 3200. 1010 get cancelled. 16 2s are 32 0. So temperature will decrease by 20 degree. So if that cloud travels altitude of 3200 meter, then temperature will decrease by 20 degree. So at sea level 20 degree temperature is there. At 3200 meter, temperature will be 0 degree approximate. If that cloud moved further higher the altitude, temperature will decrease below 0 also. Then these droplets obviously are converted into solid state and formation of snow or hailstone, whatever is there, that is there. So this way precipitation can be in form of snow, it can be in form of hailstone, or it can be simply in form of water droplet, because suppose smaller hailstones they are falling, then they are going to melt as they are entering in lower altitude, and we are getting only water, maybe possible cold water, but this is the reason. So this type of precipitation is possible if that clouds are moving at higher the altitude, particularly in summer season in India. Now my discussion is here with respect to India. So in summer season we are getting many times the thunderstorm. Because of higher temperature, this way there is movement, upward movement of cloud, and then temperature of that cloud decreases. There is already charge on cloud. Now if two oppositely charged clouds are collapsing each other, colliding each other, there is discharge that we are calling electrical discharge. So this way electrical discharge or lightning is there in sky. As it is moving in higher altitude, they are forming hailstone also. So that's why particularly in summer season, in certain parts of India, not everywhere, but in certain parts of India, this type of precipitation is observed. In particularly Bengal, Bihar, this part, that is eastern parts of India, the precipitation occurs by mixing out dry wind from north side and wet wind from south side. We are calling that as nor'wester, or in Bengali language or Hindi language they are calling as Kala Baisakhi. So this is the formation by mixing out the cloud. So this way precipitation may occur. Now this type of precipitation or whatever the rainfall, snowfall, pellets, hailstone, whatever that, this type is called as convectional precipitation. What is the convectional? Say air here become hot, it start moving in upward direction along with moisture. It is now expanding out, and still it start expanding, because of that temperature decreases. Secondly, because of expansion temperature decreases. This process here is called as adiabatic change. That is, temperature will decrease on account of expansion. Want to check? Let us check out. Say God has provided us various things, like we have compressors, we have thermometer. Thermometer is not that what we are considering. Our skin is acting as thermometer, I can feel cold weather or hot weather with skin. Same way we have compressor in our mouth. So you can carry out this same experiment with me. Number one, just take your hand, palm particularly this way, and touch to your mouth this way and blow. Just try. Again, I am explaining, this is your palm, touch it to mouth and blow it. You will find, try to get touch here. Whatever air is coming through your mouth, that is compressed air, and it is touching to your palm, you will get warm feel. Thermometer is here and compressor is here, you will get warm feel. Check out. Okay. Now second experiment, simply like that. You have to hold your hand like this at distance and simply blow and get whatever the feel is there. This is not warm, this is colder feel. There is compressor, air is compressed, it is released through mouth, but on release it start expanding out. It is getting volume to expand, and then for that expansion purpose, work done is there. For work done, energy is required. That energy is taken from within. As a result, there is decrease in heat, that means decrease in temperature. And so if you do this way, you will feel it's cold, but if you do this way, there is no expansion, only compression, you will get warmer feel. Now same thing here, as here air is starting out, moving at higher altitude, its pressure decreases. Atmospheric pressure is maximum at sea level. As we are moving higher altitude, pressure also decreases. Because of that also there is expansion, and on expansion there is decrease in temperature, like I have shown you now. So this way it will decrease. This is adiabatic process. This process is called as adiabatic process. Details in chemistry thermodynamics lecture. So this way the moist air or humid air is moving in upward direction and then causing formation of water droplets and then causing precipitation. This concept is called as convectional precipitation. Usually in equatorial region of earth, this type of precipitation is observed. This is called as convectional precipitation. In India, particularly during summer season, in month of April and May, this type of precipitation may occur, not daily, but many times it may occur. That is leading to concept that is convectional precipitation. What is the characteristic? Usually these convectional precipitations are associated with heavy rainfall, then thunderstorm, and many times fall of hailstone also in certain areas. Now for example, I am staying in Mumbai. In case of Mumbai, hailstones are not observed. Temperature already is very high. Secondly, if at all these hailstones are there at higher altitude, till reaching the surface, they start melting out. But in certain parts, say for example on plateau region, we can observe hailstone. Okay, this is about convectional type of precipitation. Now second type of precipitation here we want to discuss, that is called as orographic precipitation. Now what is this orographic precipitation? So there is mountain. Why to take this example? We are going to take real example only. In case of India we are discussing, therefore I want to take this example. Try to recollect, we discuss about various features of India. At that time we discuss about plateau region of India, South Indian plateau part. Try to get the concept. Sea, smaller coastal part of India, that is western coastal part, then Western Ghat, which is steep at western side but not that steep at eastern side, depth very high here but not here, then tilted plateau, Eastern Ghat, then eastern coastal area, and then sea level. Okay, particularly South Indian Peninsula region we discussed. I am writing here again. This is Western Ghat, this is Plateau region, this is Eastern Ghat, this is Eastern coastal area, this is Western coastal area. Now, for Western Ghat, the height or altitude from sea level is around 1000 meter. What word I am using? Around, or average height of Western Ghat is 1000 meter or 1 kilometer. Kilo stands for 1000. Now, clouds, usually the water filled clouds, they are at altitude of 500 meters. I am not saying always, usually in range of this. Sometimes they can come down also and move up. Now this is producing, say suppose this is the direction of wind, it can just strike over there. There is obstacle. This obstacle is there of Western Ghat, that is mountain range. So the clouds start moving already in upward direction and they will pass like this. So this is the direction. Because of obstacle there is wind direction. As it start moving in upward direction, you are aware temperature decreases. For every 160 meter temperature decreases by 1 degree Celsius, and pressure also decreases. You are aware, for every 160 meter pressure decreases by 1 mm of mercury. As a result, it start expanding, start cooling out, and we are getting heavy precipitation, that is in form of rainfall over this region. This precipitation is called as orographic precipitation. This type of precipitation over here is called as orographic precipitation. I am using word again. This type of precipitation, because of obstacle, air start moving out, moving up, and precipitation occur. This type of precipitation is called as orographic precipitation. In earlier example, we discussed that it's convectional precipitation. Because of only rise in temperature, air start moving in upward direction. Here, because of obstacle, air start moving in upward direction and we are getting precipitation over here. This is the reason on western coastal area, we are having tremendous rainfall in India. On Western Ghat, towards western part of Western Ghat, there is very good rainfall. But then onwards, whatever the humidity is there, this is cloud, whatever the humidity or whatever the droplets are there, they are falling here. And then the clouds may further penetrate, move, but they are already discharged out all water or maximum amount of water, and therefore in this particular area I am marking here where rainfall is not much observed, very less rainfall or sometimes zero rainfall can be observed. This is called as rain shadow territory. Usually in South India, the rain shadow territory is there at this level, not immediately after mountain, but after that there is territory where you can get still some rainfall here, but after that there is very less rainfall is observed. Now this is rain shadow part anyway. So this is the precipitation that is called as orographic precipitation. I explained this concept with respect to mountain, and in various parts of the world, orographic precipitation occurs because of this type of mountain ranges. In case of India, maximum precipitation is there because of this type of mountain ranges, particularly Western Ghat, Eastern Ghat and Himalaya mountain range are responsible for formation of this type of precipitation that is called as orographic precipitation. That's why if you cross out Himalayan mountain range, then only deserts are there, because that is rain shadow part. Not here, but just showing rain shadow part. So if you cross out Ladakh range, then there is formation of desert, particularly towards north of Jammu and Kashmir, there is perfect desert. Old Silk Route was going through that. That is called as Takli Makan. So perfect desert is there. Tibet also desert-like appearance. This is because of very less rainfall after this type of mountain range or orographic precipitation that is called as rain shadow area. This way we can have either convectional rainfall or convectional precipitation, secondly orographic precipitation, third and fourth is somewhat similar. Third type of precipitation we are discussing, that is called as cyclonic precipitation. Because of low pressure zone, there is production of cyclone. Cyclone, you are aware, various cyclones are there. They are named also, like Fayan, you are aware of that. This type of cyclones, at some part of that cyclone, air start moving in upward direction. That's all. Rest of the things you are aware, because air start moving in upward direction, it get colder, then precipitation occur. So this type of precipitation we are calling that as cyclonic precipitation. Then we are giving another part, that is frontal precipitation. Let us check out. Particularly cyclonic precipitation occurs in temperate region as well as tropical region. The temperate region cyclones, they are not intense one, whereas tropical cyclones are intense one, like in Andhra Pradesh, then Orissa or Odisha and West Bengal. These three states of India, they are prone to cyclone region lateral, but they are prone to cyclone, and cyclones are hitting out on this area. They are tropical cyclones. But in temperate region, the cyclones are not that destructive. That word is important. Now here we are going to frontal precipitation. Frontal precipitation usually occurs in colder zone or temperate zone. What is the exact concept? Try to understand. This is landmass. Say, this is the place where cold air is there, whereas this is the place where hot air is there, or warm. Rather, instead of hot, I should use word here, warm. They are colliding because of reasons, various reasons. Now you are aware, cold air is having less volume, that means more density. Warm air is having more volume, that means less density. So this cold air is dense and warm air is not that dense. As a result, on mixing, there is formation of front where hot air moves in upward direction and cold air take downward direction. Now as hot air, we started moving in upward direction, and this air, whatever the cold air that is moving in downward direction, there is formation of front, and then as it is moving in upward direction, it is getting cold. Rest of the thing, precipitation occur. This type of precipitation is called as frontal precipitation. Now usually this type of mixing may lead to cyclonic condition, and that's why frontal precipitation is also many times referred as cyclonic precipitation only. So this way we discuss about four type of precipitation. First one, that is convectional precipitation. Second one, for convectional precipitation usually occurs in region of equator. Then convectional orographic precipitation, that occurs when obstacle like mountain ranges are there. The third one, that is cyclonic precipitation, tropical as well as temperate zone. And fourth one, that is mixing of here, that is called as frontal type of precipitation. So this way rainfall occur generally.